Okay, students, we're still talking about bone. I have changed PowerPoints now from Bone 1 in my A&P 1 PowerPoint section to Bone 2. So I'm on Bone 2, and the subject now is going to be osteogenesis, which also means bone development. So let's see where we go with this. Osteogenesis is the formation of bone. Okay, bone starts about the second month of development until adulthood. Okay, then you have bone remodeling and repair, which you're doing even if you're 80. Okay, just a lot less of it. So here is kind of an idea of how it goes, not for you to necessarily memorize. About the third, okay, bone is a connective tissue, so it's going to be made from mesoderm, then mesenchyme. About the third week in this developing embryo, you'll see something called a somite. These are somites here. The fourth week, from the somites, you develop this mesenchyme. Then about the fifth week, what will happen is you'll start to see limb buds to occur. And then about the sixth week, hand plates and feet plates that would occur. And then about the eighth week, you'll start to see your first bone center. So when you look at that, here you're seeing this is about 12 weeks. At 12 weeks, all areas that's going to make bone should have at least started. All areas that are going to make bone should have at least started making bone. And those areas are called ossification centers. So again, the first time that you actually will see anything as far as bone is about the eighth week. About the eighth week in utero. Okay? And so that's kind of what we're starting to see. That's bone. Now, prior to that, you'll see a hyaline cartilage model. So we're going to be talking about something called endochondral bone formation. Endochondral bone formation is where you make bone on top of cartilage. It's where you make bone on top of cartilage. And so about the sixth week, you'll see this cartilage come about, but it's the eighth week that you'll start to see evidence of some bone formation. Again, just to kind of give you an idea of the bone development timeline. Okay. So we go back. The embryonic scale ossifies predictably, so fetal age can be determined. One of the ways of us being able to determine fetal age, particularly after you're born. After you're born, we do certain scores to try to tell how far along the newborn is. Because see, sometimes we may not know what the gestational age is of the female. She may not have had prenatal care. So at birth, most long bones are well ossified except the epiphyses. Okay, and we'll talk about that. Nearly all bones completely ossified by age 25. Nearly all. Now the clavicles will keep growing in the male for a while longer. Okay. You have some areas in the ribs that won't ossify until about 40 actually. The xiphoid process, which you don't know yet, also is like that. Bone mass decreases as age begins in the fourth decade, 40. So you go up to about the 20s and 30s, and then it starts dropping off. Rate of loss is determined by genetics and environmental factors. You know, what's your calcium balance? What kind of work do you do? Do you exercise? Stuff like that. And in old age, bone reabsorption, taking away, predominates. Now, I want to say this, though. If you are a person that works out both in aerobic exercise and strength building, then you won't really age as fast. You see, other words, there's so many disparities between aging that you have to look at that. Okay? So I always say, this is my personal, that we have three ages. Our chronological age, which is the actual age in years. We have our psychological age. How young do we think, or how old do we think? And then we have a physical age, which has to do with different things about the body. So somebody could be chronologically 18, psychologically 12, and physically 30. So again, there's disparities when it comes to aging. All right, let's go a little further though. If you recall, this is where we came up with this cell, which was a mesenchyme, and we said it could make several things, and some of what it could make, of course, was bone. Some of what it could make was bone, and so that would be osteogenesis and so forth. Okay, let's go back here. All right, now, I want you, just like we did in the previous one, it is good to look at a movie. I think my PowerPoints are okay and my videos are okay. I mean, they're okay. It's something I'm doing since I'm doing this online. But they still are static. They still are static. And I don't really have action videos. I've made some for other things, but not this. So I would suggest that you look at this before and after we talk about these two processes, intramembranous bone formation. You may want to look at it before and then look at the specifics in my video and then look at it again after. But anyway, I wanted to put that in. Okay. Now, the types of bone formation, how we form bone, there are two basic methods. One is called intramembranous bone formation, and the other is called endochondral. One is called intramembranous, and the other is called endochondral. Okay. Intramembranous bone formation is where you lay a soft membrane down and you start putting bone inside that soft membrane. You lay a soft membrane down and and it works real well for bones that don't need a whole heck of a lot of shape, like the flat bones. I always think about when I was in the 5th, 6th, and 7th grade, we would do paper mache, and we'd have a little flat paper mache, and that was easy to make for me. I wasn't a great artist. But if we had to sculpture something, it became very much harder. So the flat bones are easier to make. So you would lay a membrane down and ossify within the membrane. The long bones and some of the others, irregular, sometimes are harder to make because of their three-dimensional design. So you need a model, like a prototype in the car industry. You know how the car industry does a prototype. So you use so the body makes a cartilage model, and then you ossify over that model. You ossify over that model. Now, I name a third one for me called ectopic bone formation. Ectopic means out of position. Sometimes bone can be formed in soft tissue. We said in a previous video that the fibroblasts lay down collagen and AGS, amorphous ground, and it stays soft. But if you irritate the fibroblast, which is the brother of the osteoblast, they can start releasing that type of collagen and those glycoproteins that can cause calcium to rain out of solution and make an area get hard. So if you irritate a soft tissue too long, like bone spurs, kidney stones, stuff like that, if you irritate, then you will start to form bone there. It's called ectopic bone formation. Actually, your kneecap, known as the Patellar Tendon, the tendon that holds the patella bone, really was an ectopic bone formation through irritation when you bend in the knee as a very young. But really two major ones, intramembranous and endochondral. Intramembranous and endochondral. Okay. Intramembranous bone formation, ossification center appear in the fibrous connective tissue, soft connective tissue, just like this here. These ossification centers occur because these mesenchyme cells start to differentiate into osteoblast. When they do that, they start forming that. Okay. Then what will happen? The bone matrix, osteoid, is secreted. Now the bone matrix, remember, is the organic matrix. The organic matrix, which the osteoblast secreted, was the fibers and the amorphous ground substance. Remember, that was osteoid. Osteoid is bone before it's mineralized. The osteoblasts begin to secrete osteoid, which is calcified within a few days. The osteoid is osteoid. When it's calcified, it becomes bone. The osteoblasts now are trapped in here. But you see how these arms are sticking out? See, they're forming connections we talked about. They're forming connections we talked about in order to form that haversion or pseudo-haversion system. Okay. When they get surrounded by bone, they don't get enough oxygen, so they become osteocytes. See, it's following the same thing. Okay. Here's the bone being made in this here. Now, this is spongy bone. These are making spongy bone. Actually, I'm going to be very honest. All bone is spongy at first. Let me kind of explain. All bone is spongy at first. As you put weight on it, it will get more compact based upon the weight. Okay, the way I analogize that is this. If you get ready to paint your wall, what do? Put a coat on, but it's real thin. You let it dry, then you put a second coat on. The first coat is kind of thin. So when bone is first laid down, it's kind of thin. It's more of a cancellous or spongy bone. But if this area needs to get stronger, pressure would be put on it, and then it will start to get more of a compact. But anyway, woven bone and periosteal bone. Woven means that it's a soft bone that's been woven. Accumulated osteoid is laid down between the embryonic blood vessels. See, the blood vessels are invading in here, the blood vessels. And the result is a network of trabeculae. See, this is staying right now as spongy bone because trabeculae are in spongy bone. Spongy bone can also be called cancellous bone or woven bone. Okay. Here we are. See, this is getting a little more compact now. Lamellar replaces woven bone. See that lamellar bone? But how did that occur? This particular area started getting pressure put on it. And that spongy bone would have cracked immediately. So with that pressure, you start to develop more compact bone, which gives the true eversion system. This is the pseudo. Okay, you kind of read on it, but also look at that video I mentioned. So that's how intramembranous bone formation occurs. That's how intramembranous bone formation. Okay, our next one is going to be endochondral. But before we can do endochondral, we have to discuss cartilage. Remember, I left cartilage out of chapter 4 because I said we would discuss it here. So what I'm going to do is close this video out and then start on a new video, which will start on endochondral bone formation. But do not forget, those motion videos are real good to look at to kind of get a good idea. Okay.